Welcome to the lecture. This is the first lecture in this Python programming course. Today we are going to discuss some basics of Python. We are going to start with the introduction and then talk about Python interpreter and then some features, versions of Python. I'm also going to talk about computer, a little bit about hardware and about how everything works behind the hood in the computer, about the hardware, how we execute the programs. So in this course, we are going to cover various topics. This is the main agenda of this course. We'll start with the introduction. We'll start with the language fundamentals. We'll go on with the data structures and functions, modules, object-oriented programming. The OOPS concepts will be taught in very detail. We'll cover each and every topic in the OOPS. Then we'll continue with exception handling, file handling, serialization, generators, decorators. Each and every topic will be covered very thoroughly. Every topic will be taught in very detailed manner. And after completion of this core Python course, I'm going to start a course on statistics and then NumPy, Pandas. Whatever topic I teach in these courses, everything will be everything will be taught in a detailed manner. We'll go very deep into each and every topic, and we'll try to understand the main main the core concepts of each and every topic instead of just memorizing formulas and just going just learning it on the top level. So let's get started with today's lecture. So before getting into programming and before talking about Python programming language, I want to talk about different types of knowledge that exist in this world. So there are different types of knowledges like general knowledge, explicit knowledge, implicit knowledge. There is something called domain specific knowledge. There are more than 10 plus types of knowledges in this world, especially in the English language. So in this lecture, I want to talk about two types of knowledges. The first one is declarative and the other one is imperative knowledge. So if I state something, if I give a statement, or if I talk about any fact, for example, if I give a statement to any of you like you are a good person, this is a statement or a compliment. You're a good person. So this statement comes under the declarative knowledge. Or if I tell a fact, if I tell 2 plus 2 is equal to 4, this is a fact. Okay, 2 plus 2 is equal to 4, that's a fact. So I'm stating a fact. So this comes under the declarative knowledge. Or if I ask you a question, or if I say anything, okay, today today it's cold, I'm telling you something. It comes under the declarative knowledge. If I say a fact that New Delhi is the capital of India, it comes under the declarative knowledge. So basically, if I talk about any fact or if I give a statement, all these things comes under the declarative knowledge. And we have another type of knowledge called imperative knowledge. Imperative knowledge is about algorithms. It's about writing algorithms. Algorithms is nothing but a sequence of steps to do something. Okay, it's like a sequence of steps to do something. Sequence of steps to do something. To do something. So for example, if I want to make a tea, then I can list out a couple of steps, like I need to put the bowl on the stove, I need to lit the stove, I need to pour some milk, I need to put some tea powder, etc. And there are so many steps. Okay, I can list out each and every step in a paper, and I can call all these steps as an algorithm. It's like a recipe, or we can say that how to do something. Okay, it's like how to do something, how to do. Okay, telling how to do, and writing algorithms, or algorithm is nothing but telling how to do. Okay, how to make tea, how to do anything, all this comes under the algorithm. So like the whole thing of the whole concept of how to do is it comes under the imperative knowledge. The concept of how to do and all these algorithms, recipes, all these kind of things comes under the imperative knowledge. So programming is all about writing recipes to generate facts. It's about creating imperative knowledge. Programming is all about creating imperative knowledge. So for example, if I want to generate a fact that 2 plus 2 is equal to 4, what I can do, I need to write a program. So I can define a variable. Variable is nothing but an alphabet or a letter, where I can, store something. So I'm storing the value 2 here. I'm declaring another one, and I'm storing value 2 here, and I'm going to add it, and I'm going to print it. So what I did here, I added two numbers, and I'm going to print the result of these two numbers on the computer. So this is nothing but a program, or this could be called as an algorithm to print 4. So to generate a fact that 2 plus 2 is equal to 4, I wrote an algorithm. So this comes under the imperative knowledge. Creating imperative knowledge is nothing but programming. The main concept of programming is nothing but creating imperative knowledge. It's about writing recipes, or we can say writing algorithms, programs, everything. So that's the basic idea of programming. So for example, if I want to if I want to find a square root of a number, if I want to find a square root of number y, then I can do something like this. I can save a number here. I can save a number into y, and then I can directly use an operator called square root, and then I can get this value, and I can store it in the another variable. So this is nothing but a program. It has two steps. The first step is to assign a number to the variable, and the other step is to print it, okay, to actually find the square root and print it on the output. So this is nothing but an algorithm that we'll use to write programs, and so that we can show the output on the computer. So the main concept of programming is about how to let the computer, execute these programs, or write these programs, or generate facts. That's the main concept of programming. We need to let the computer do all this stuff. And a computer only does what we tell it to do, okay? If I have a computer in my home, the computer won't do anything unless I tell the computer to do something, okay? If I tell the computer to print something, it will print it. If I tell the computer to send a message, it will send a message. So like without telling anything to the computer will just sit idle. It won't do anything. So I need to tell the computer what to do, then only the computer will do something. I need to give an input about what to do. For example, if I give an input to print 4, then the computer will print 4. If I tell the computer to send a message, then the computer will send a message. If I tell the computer to download something, then the computer will download it. So I need to tell the computer what to do, and the computer will only do what we tell the computer to do. For example, if I tell the computer to print 4, then it will only print 4. It will never print 9, or it will never print other number other than 4. So if I tell the computer to send a message to someone in particular, the computer will only send the message to that particular person. It won't send it to anyone. So the computer only does what we tell the computer to do. So we need to make sure that we should give correct instructions, so that the computer will do whatever we want to do. If we give wrong instructions, then the computer will do something else. So we need to make sure, the whole concept of programming is about giving right instructions, so that the computer will do what we want the computer to do. So algorithms is nothing but sequence of steps that I already told you. It's nothing but sequence of steps to do something, okay, to do something. So the main concept of programming is nothing but writing programs based on these algorithms. So here I want to talk about the basic architecture of the computer. So this is the basic architecture. This is memory. This is memory. This is the CPU. CPU has two units: arithmetic logic unit and the control unit. Control unit is the one which guides the computer, okay, which guides the CPU, which tells the ALU what to do and how to do. The control unit is the whole, it's like an heart of the CPU. It will tell the ALU what to do, so that the ALU will perform the instructions. The ALU's main function is to perform the operations. It's the main function of the ALU, and the control unit will guide it. Will guide the ALU to do this. This is nothing but the program counter. So if I have 3048 as an address, then the computer will execute the instruction in this particular address. So program counter will always stores the next instruction that we need to execute something. It will always store the next instruction. If I want to add something, then there will be an instruction in the CPU to add two numbers, and the program counter will have the address of that instruction. After completion of that instruction, program counter will be incremented, so 3048 will become 3049, and we have another instruction in 3049 address, then that will get executed. Okay, the program counter is kind of an important thing because it stores the last instruction, so it kinds of fulfills the main idea of the execution. Okay, so and this is the input. We will give input from here. We'll tell the CPU to add something, then the CPU will add two numbers, and it will give the output from here. So this is the basic architecture of the computer, and let's take an example to understand the architecture here. So in the memory we have two numbers in the address 30 at the address 3056 and at the address 3057. I have 3 at 3056 and 4 at 3457. So in the CPU, so this is the ALU, so this is the CPU. So what we are going to do here is that we have an instruction here to add 3056 and 3057. Inside 3056 I have 3, inside at the location 3057 I have 4. So I'm going to add these two numbers, 3 plus 4, the answer will be 7. Then I'm going to store the result at 3058. So here I'm going to store the result 3058. The result will be stored here. And actually, before the execution, the program counter's value will be 3046. First, we'll fetch the 3, and then it will get incremented. 3057 will get 4, and then it will be incremented, and then we'll store it in the at the 3058 location. After that, we can also compare these two numbers, 3056 and 3057. If I compare these two numbers, then obviously these two are not equal. Okay, the compare instruction depends on whether we are trying to find if they are equal, whether we are trying to find if 3056 is less than 3057, if it's greater than it depends on the instruction. But if I want to compare if they are equal, then obviously they are not equal, then I'm going to store false at this location because I compared it, both are not equal. Then I'm going to store false here. Then I can print the value 7, then output will be printed with 7. So this is the basic, this is how the computer executes the instruction. We'll get into the details in a bit, like how exactly everything goes on inside the hardware. So before getting into that, I want to tell you something. So before execution of any instruction, okay, before the execution of any program, the operating system will do a small task here. We have a source code here. For example, I have a code like A is equal to 10, B is equal to 20, and I'm printing A plus B. So this is the basic program I have here. So first, the computer, the operating system needs to change this program into the machine code, okay? It will change this program into something called as machine code. The machine code is nothing but a group of zeros and ones. So in this machine code, the 0 is nothing but the low voltage in a transistor. This could be a transistor like this. So inside the transistor, like the output could be either 0 or 1. 0 means low voltage and 1 means high voltage. So if the current is passing through this circuit, then the voltage will be high because the electricity is passing through the circuit. If the electricity is not passing through the circuit, then the voltage will be low. So based on these two voltages, we store the data inside the computer with the help of the transistors. The transistor can only have one state. It can either have 0 or 1. So if we have 0, then it's low voltage. If we have 1, it's high voltage. So that's how the data is stored in the computer, on the chip of the hardware. So the machine code is nothing but zeros and ones, and we all know that 0 is nothing but low voltage, 1 is nothing but the high voltage. So the operating system needs to convert this program into something called machine code. So the operating system will load the binary code, or we can also call it as binary code. The machine code and the binary code are used interchangeably. So the operating system will will load this machine code or the binary code into the main memory RAM and executes it. So for the program to get executed, the program should be inside the RAM. So in our mobile phone or in our computer, we have two types of memories, RAM and ROM. ROM is nothing but the secondary storage, and RAM is the main memory. So if we want to execute any computer, sorry, I mean, if you want to execute any program or any application, for example, if I have WhatsApp, right? We have WhatsApp in our, so whenever I click on this WhatsApp, all the programs related to this WhatsApp will be loaded into this RAM, and the operating system will start executing like each and every instruction. I mean, it will take care of the everything, and it will send it to the hardware, it will send it to the CPU, and CPU will start executing everything. So the source code should be converted into the binary code. So for the conversion, we need something called compiler. Okay, we need something called compiler here. The source code will give it to the compiler, and the compiler will convert this source code into the binary code. Binary code is nothing but the zeros and ones. So if we want to execute any program, we need a compiler in our system. So if I want to execute a Java program, then I need to have JVM. If I want to execute C program, then I need to have the C compiler. If I want to execute the Python program, then I need to have the PVM. Inside the PVM, we have something called compiler, which will convert the source code into the binary code. Okay. So I want to talk something about the execution process, the whole program execution progress, the concept. So how computer runs a program. So we have three steps in the execution of the programs. So first step is the fetch, second is the decode, and third is execute. Fetch is nothing but getting the instructions. It's like fetching the instructions from the memory, and the CPU will fetch the instruction from the RAM, getting the instruction from RAM to the CPU. So the CPU will fetch the instruction first, it will decode it. Decoding is nothing but understanding the instruction. We need to understand what kind of instruction it is, whether it's an instruction to add two numbers, whether the instruction is subtraction, whether the instruction is multiplication, whether it's something else. We need to decode it. Okay, the CPU will understand what the instruction is. After understanding what the instruction is, after getting the data, it will execute the instruction. That's the third step here, execution. Okay, so these are the three steps that the computer will do. So combinedly, these three steps is called as an instruction cycle. So if you have 1,000 instructions, for each and every instruction, these three steps will be followed. The instruction will be fetched, it will be decoded, it will be executed. These three steps will be, will be applicable to each and every instruction in a program. If program have 1,000 instructions, 1 lakh instructions, for every instruction, each and every instruction, these three steps will be applicable. These three steps. Okay. So we'll talk about instruction now. So instruction is nothing but a bit, it's like a group of bits which instructs the computer to perform a particular operation. Here, if you have an instruction, for example, let's take an 8-bit instruction here. We can it depends on the processor. Okay, the number of bits depends on the processor. It differs from one processor to another processor. For example, if I'm going to take an 8-bit instruction, I'll divide this instruction into two parts. So for example, if I have 8 instructions in my processor, then I can, how many bits I can put for the opcode? I can put 3 bits. Then for the 5 bits, I can put the operand information. So each and every instruction is divided into two parts. The one part is operand information, or we can call it as data. This is opcode. Okay. If I have 8 instructions, I can make the opcode 3 bits. If I have more instructions, then I need to specify more bits for the opcode. So an instruction in a program, this is a program, we can have so many instructions: instruction 1, instruction 2, 3, 4, 5. Each instruction is divided into two parts. So here the opcode is nothing but the type of the instruction. If I if I want to let the computer know what kind of instruction it is, then I need to specify the opcode. Opcode will specify the type of instruction. And this is nothing but the operand information. For example, if I have if I'm going to add two numbers, 2 plus 2, these are nothing but operands, so we'll give the operands here. So this is nothing but we can call it as data. Okay, we can call it as data. The opcode is nothing but the type of instruction, like whether it's addition, whether it's subtraction, whether it's multiplication, whether it's increment, it depends. Okay, based on this opcode, the computer will understand what type of instruction we want to execute on these two numbers. Okay, on this data, what kind of instruction we want to execute, we'll specify using the opcode. So there is something called instruction set architecture, and each and every processor, it's the ISA, it's also called as ISA, instruction set architecture. It's nothing but the collection of all instruction supported by CPU. So here I told you, right, for every instruction we are going to divide into two parts. The first one is the opcode. Here I took the opcode as 3 bits, so I'm going to write some instructions here. So if we have 3 bits, then we can write something like this: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1. So yeah, so I can get 8 instructions with 3 bits, so it's nothing but 2 power 3. That's the reason I used 3 bits for the opcode. We have, because I'm assuming that I have eight instructions in my computer, in my processor. So that's the reason, like just because I have 8 instructions, I can use 3 bits to represent all the instructions. So for this code, I can I can represent addition operation with this code. I can represent subtraction with this. I can represent multiplication. I can represent increment. I can, there is something called load operation. I can represent using this one. What else we can have so many instructions, like there could be other instructions, like for each and every instruction there will be a particular code. So here I told you that opcode will tell the computer what kind of instruction that we are going to execute. So based on the opcode, so if you have 000, then addition will be executed on this operation, like on this data. And if I have 001, then subtraction. Then if I have 010, multiplication, based on the opcode. Okay, based on the opcode, computer will understand what kind of operation that we need to execute. That's the basic idea of instruction and the instruction set architecture. So mainly the instruction set architecture is the collection of instruction, and I also want to say something, that all these instructions are not they are like dependent to the processor. The meaning of dependence is, for example, if I if I have two processors, the first one is Intel and the other one is ARM, then the instructions that are understandable by Intel processor cannot be understandable, like the ARM cannot understand these instructions. If I have 8 instructions in the Intel processor, then the ARM can't understand these 8 instructions. If I'm going to represent addition with 000 here, then I might represent with 0010 like this in the ARM processor. So this instruction are dependent to this processor. Okay, if the Intel can understand this instruction, it doesn't mean that ARM can also understand that. So the instructions are, they are not they're different in each and every processor. So it depends on the processor. Okay, if you're using a different processor, then there might be a different architecture, there might be the different instruction code that they are going to use for that. So here I drew a diagram for this one. This is the memory, this is a processor. So the memory is divided into two parts. The first part is nothing but the program, and the data will be stored separately inside the memory. So this is the processor. So we are going to fetch these instructions into the processor, and we are going to execute one by one. So we have three steps: fetch, decode, execute, that we already discussed. So instructions are dependent to the processor. So this machine code, for example, if I you know if I am going to generate a machine code like this, 00111, this is a machine code. If this machine code is understandable by Intel, then the ARM could not understand the machine code. So for the same program, I need to generate a different machine code inside the ARM processor. I need to generate a different machine code in the Intel so that the processor can understand these programs. Okay. So I want to explain you the basic architecture that we already discussed, but I want to talk about the flowchart. I want to give you a flowchart about how the execution takes place inside the computer. Mm, So this is the processor. We have a memory here. So I'm going to have a program counter here. This is program counter, and I can have some registers here, like let's call it as an instruction register. We can have some data registers here. Data registers. Let's make the ALU here. This is the arithmetic logic unit, and we also have something called accumulator. So this is the memory here. So in the memory, I have some instructions here. This is the instruction 1, instruction 2, instruction 3, and below this one I have some data here. I have three variables. I have A, I have B, and I have C. Okay, this is the memory, and this is the processor. This is the CPU. We also have the control unit inside this, but I'm not drawing the control unit because the space is not sufficient. So I'm going to explain you the flowchart here. So like I said, the first step is nothing but fetch. We need to fetch the instruction inside the CPU. So inside the memory, this memory is nothing but RAM. Okay, this is RAM. So first I'm going to fetch it. I'm going to fetch the instruction from the memory to the instruction register. So instruction register is used to store the instruction temporarily. So I'm going to get this instruction. Okay, let's write some addresses here: 346, 347, 348. Let's also write something like this: 400. I'm sorry, 400, 401, 402. So in the program counter, I'm going to have the address of the next instruction. So here I'm going to execute the instruction 1. So I have 346 here. So based on this program counter, this is nothing but the program counter. So I have the instruction 346, and the instruction 1 is getting fetched here. This is the first step, which is fetch. So the instruction 1 will come to the instruction register. So after fetching the instruction, what's the second step that we discussed? The second step is decode. Decode is nothing but understanding the instruction. So after getting the instruction here, I'm going to decode it. I'm going to understand the instructions. Like I said, the instruction is of two parts. The first one is opcode, and the next one is data. So based on the opcode, I'm trying to understand what kind of instruction it is. So for example, if the opcode is 0, then like we already designed some instructions before. 000 is nothing but add. Let's assume we have 00 here, like 3 zeros in the opcode. So we have 3 zeros here, which is nothing but the opcode here. This is nothing but the opcode. So based on the opcode, I'm going to understand that it is the addition operation. So after decoding it, then I'm going to fetch the data here. So I need some data. So inside the data, I have some addresses. So we have 4011. So first, this will get executed. The program counter will be incremented here. So first we have 346. Now it will be incremented 347. So the instruction um, so the instruction 2 will get fetched here. So inside the instruction, we could have an instruction to fetch this data. So we could have an instructions to fetch this data A. So I'm going to fetch this data A to the data register, and the whole instruction 2 is about fetching the giving the addresses of the data. So next, the B will be fetched to the instruction, I mean to the data register. This is also the fetch operation, but this is data fetch. This is data fetching. So after bringing the data into here, I'm going to give it to the ALU here, and the ALU will perform the addition operation because we already understood what kind of operation it is. So it will execute the addition operation and the result will be stored. Let's assume the A is 10 and B is 11, 20, then 10 plus 20 is nothing but 30. And this accumulator, we could have another instruction. The program counter will be will be incremented to 348. In the instruction 3, we could we could write to store this result into this variable. Okay, this is nothing but write back the result. So this part is nothing but the execution part. The third step is execution. So this is the idea of the how the idea of the architecture, how we execute, how the computer executes the instructions. So I hope you understood the way we execute the instruction, the way the computer executes the instructions in the CPU. So also, as I said, in the memory, this is nothing but the machine code. Okay, you should also remember the fact that all the instructions are in the machine code. So like I said, the source code should be converted into the machine code. The operating system will do that. We need to have a compiler. So with the help of the compiler, the program will get converted into zeros and ones. So like I already said, 0 is nothing but the low voltage, Y is nothing but the high voltage of a transistor. So this is the basic idea of how computer executes the instructions. I hope you understood. So then we will start. Now we'll start with the Python programming. I talked about the whole thing about the computer architecture, and I talked about how computer executes instructions. We talked about different types of knowledges. We talked about why we need programming. So like I said, we need programming to write algorithms. So there are various types of programming languages in this world, like C, C++, Golang, Python, Java, JavaScript, various types of languages. So first we need to understand that if you're going to design a programming language, first we need to understand that why we need to create a programming language when we already have our own languages like Telugu, English, Hindi, Malayalam, or whatever language that we talk. Like if we already have a language that we speak, why we should even think of creating a programming language. So we will talk something about the basic some basic concepts of the English language. So this is the basic syntax. For every language there will be a particular syntax. Okay, whether it's English, whether it's Telugu, whether it's a programming language, there will be a syntax, there will be some rules, and everyone should follow that rules. If we don't follow that rules, then we will call it as a syntax error. Okay, for example, in English, if I write something like this, okay, cat, dog, boy, then there is no meaning for this because it's not even syntactically correct. Okay, the grammar is not correct. We haven't used any verbs, or we haven't used anything. Okay, we haven't used any helping verbs like is, are, whatever it is, like all the helping verbs, we haven't used anything. So it's not even syntactically correct. So for every language, there are some rules that we need to follow. Even in English, there are some rules that we need to follow. If we don't follow that rules, then we will say that it's syntactically invalid. Okay, it's not syntactically valid. So what if I say something like this? Okay, if I say that cat hugs boys, then there is some meaning to it. So we can say that it's syntactically valid. I can say this because it's grammatically correct. So at the same time, if I talk about a programming language, there is a syntax. Okay, for each and every programming language there is a syntax. We have some rules that we need to follow. So for example, if I write something like this, okay, I wrote a string hi, and then an integer is followed. So doesn't sound, it doesn't have any meaning. Okay, I wrote something called hi, and then I wrote 5, then it doesn't mean anything. So this is syntactically invalid. Okay, this is not syntactically valid. So I need to put an operator here. So this is nothing but the multiplication operator. So if I put an operator here, then that makes sense. Okay, we are performing an operation. We are performing an operation between this string and this integer. So now I can call it. I can say that this expression is syntactically valid. So the main point here is that for every language there will be some rules. We need to follow that rules. So there are two types of errors that I can think of in English language. The first one is the syntax error that we already discussed. Um, it's syntax error. And the other one is static semantic error. Static semantic error. Static semantic error is something that occurs when the syntax is correct, but the meaning is not correct. Okay. For example, here I are hungry. This is this is grammatically correct. I mean, we are using I is nothing but the first person. I'm using a helping verb, and I want to tell someone that I'm hungry, but it doesn't follow all the rules, and it doesn't make any sense that I are hungry. I need to tell that I'm hungry. So this is syntactically valid because we are using everything. I mean, we are using a first person. We are using the helping verb. We are stating that I'm hungry. It's syntactically valid, but it's not. It doesn't have any meaning. Okay, that's called the static semantic error. At the same time, in the programming language, so whenever we write a program, we will tell the computer to do something. For example, if I want to tell you, if I want to take an example, that for example, if I'm writing a program to launch a missile on a country. So this is a country here, and it has so many neighboring countries. It has so many neighboring countries like this, and I want to launch a missile. I want to write a program. So I write a program to launch a missile. I have a missile here, and I want to launch a missile on this country. Okay, on this particular country, I want to launch a missile. So I write a program here. The program is syntactically correct, but instead of I made a small error in this program. So instead of launching this missile into this country, I launched this missile into this country. Then unnecessarily I'm maybe for example this country is a friend of mine, then obviously I'm unnecessarily creating conflicts between friends. So the program is syntactically correct, but the program is not doing something that I want the program to do. That's called the static semantic error. So the program should always do, as I said, the computer should always do what we want the computer to do. If we want the computer to, if we want any device or software to launch a missile into this country, it should launch a missile to this country. It shouldn't launch the missile into some other country. So if I use English language or if I use Telugu, then there is so much there is it's a lot of difficulty. There is a lot of difficulty in these languages. There is some ambiguity in this language, in these languages like English, Telugu, all these languages. There is some ambiguity in this language. For example, in English we can have many meanings. So I can say that the chicken is ready to eat. These statements can tell you two different meanings. First, I can assume that the chicken is ready, that the chicken is cooked, so that I can go and eat the chicken. So this could be one interpretation of this statement. And I can also say that chicken is nothing but hen, and the hen is ready to eat something. Okay, this could be the second interpretation. The first interpretation is there is a chicken and I am ready to eat. The chicken is ready to eat for me. The chicken is ready, but the second interpretation is the chicken is ready to eat something else. So there is some ambiguity here. So if I give this statement to a computer, then the computer will get confused. Okay, the computer will not understand what exactly the computer should do. So there is an ambiguity. The sentence have two meanings. So in all these languages, that English, Telugu, Hindi, French, in all these languages, there is some ambiguity. That's the reason we need the programming language here. So programs can only have one meaning. We cannot give two meanings to the program. The program should only have one meaning. But usually, as I said, if I want to launch a missile, then if I make a small error, even though it's syntactically correct, then the meaning is probably not correct. So sometimes in programs, the meaning may not be what the programmer is intended to do. If I intend to write a program to launch a missile to a country A, then maybe it will launch the country to the country B. Then that's not how the program should be. Mostly the errors in programming will occur in the errors are nothing but the semantic errors. We might be very good in writing the syntax, but the meaning, we need to focus on the meaning too. Okay, the program should be able to do what we want the program to do. So that we need to focus on. In the whole course, we'll solve so many problems, and we'll try to understand how to write programs and how to solve different kinds of problems. So let's get started here. Now we are going to introduce this Python. So Python is a programming language. We have so many languages like C, Java, C++, so many other languages, R, Golang. So Python is one of the programming languages that we use in the current market. So there are so many uses of Python. We'll discuss that in a bit. So Python is a general purpose high programming language. So in programming languages, we have two types of languages. The first one is high level programming language, and the second one is low level programming language. High level programming languages are C, Java, Python, and the low level languages are the languages called as the assembly languages that we use to code the operating, like the processors. Okay. So these are two types of languages. Assembly language is a bit tough for us. It's very complicated to code in the assembly language. That's the reason we use high level languages like C, Java, Python, and other programming languages. So Python was developed by Van Rossum in 1989. He was working in the National Research Institute at Netherlands. Like based on a project that he was doing, he developed this programming language, and this language was made available to the public in 1991. So that's the reason we say that the official date of birth of Python is 1991. In particular, it's Feb 20th, 1991, the official date of birth of the Python programming language. Okay. And I also want to state a fact here. The name Python is taken from a show name called Monty Python Circus. If I'm not wrong, I think this is the show name, Monty Python Circus. So based on this show name, this person named this programming language as Python. And Python is recommended as the first programming languages for beginners. So like, even if you ask anyone, if you ask any senior, they'll say that Python is very easy. You can easily learn Python. Like for all the beginners, people are going to suggest this Python programming languages. So let's check if this is valid or not. So this is a program in Java. In Java, just to print hello world, this is the program that we need to write in Java to print a small text. Okay, to print a small text, hello world. This is the program in Java. I created a class here, and I gave a name to this class called hello world. This is nothing but the class, and inside the class, I declare the main method. This is a static method, the main method. Inside the main method, I wrote a print statement, hello world. So even, if you look at this program, you can find so many keywords here. You can find something called static. You can find void. This is nothing but the string array. You can find this one, args. This is nothing but, the command line arguments. Even here, you can see so many keywords here, system, out, println. Here in this line, system is nothing but a class. Okay. It's a class, and out is nothing but a variable, and this is a method, and this is a static method. Okay, this is a static method. That's the reason I'm going to use this method using the class name. Okay, in Java, all the static methods are accessed using the class name. So if you look at this code, then it's a bit complicated. Okay, you need to know a lot of things. You need to understand each and every keyword. So obviously it's going to be a bit tough for a beginner to understand Java. So let's see another code in C language. So in C language, this is the code to print hello. This is the same code to print hello here. So I just declared a main method, void main. This is the main method. Inside this, I used a small method. This is, this is very small compared to Java. Okay, printf, and I'm printing the hello, and the output will print hello. So as compared to Java, the C language is the code in C language is a bit small. So Java is like for a beginner. Java is a bit complicated than C. So let's see how we can print hello in Python. So this is the basic syntax of Python. That's the reason people say that Python is very easy language. Okay, people say that it's for a beginner, Python is very recommended. Okay, we recommend Python to a beginner, because to just print hello world, I'm just going to use one line. If I just use one line print, then I'm going to execute this instruction. Like I'll try to execute this in the so I'm going to execute this and show you in Python. Okay, keep okay, it's in the opera. So here I'm just this is the Jupyter notebook. I launched this Jupyter notebook using Anaconda. You can download Anaconda on Google. You can just search Anaconda download, and you will get a website on the top. Just go to that website and download Anaconda. And inside the Anaconda, you will, like, after opening the Anaconda, you will find all these things, and you can launch the Jupyter notebook from here. There is also something called Spider here. This is the Python IDE to make different types of projects. We can also use PyCharm using this Anaconda. So mostly in this course, I want to use Jupyter Notebook because it's a bit easy to use, and we can just execute very easily, and it's a bit easy compared to the PyCharm and the other IDEs. Okay. So I'm just going to write a small code here, Python hello. Then if I execute this, I got the output hello. Okay, only one line. I'm just going to execute one line, then I got the output hello. So that's the reason people say that the Python is very easy language. The syntax is very easy to understand and learn. So here, the syntax is very easy and easy to understand. So to execute Python programs, we have several ways to execute Python programs. We can use the IDE. We can use the IDE like interactive development environment. We can using the interactive prompt provided by the Python. So if you want to install Python, go to Google, type Python download. You will get the latest version. I think the latest version is 3.3 or 3.2. I'm not really sure. So just click download Python 3.2. You will go to the website and download it. So after downloading the website, you can go to the search bar and you can click Python here. Then here you will find something called IDLE here. IDLE is nothing but the interactive prompt. Okay, it's we can directly execute the instructions here. So I can write hello, and I can execute the instruction. So if I want to do something like 2 plus 3, then we can execute it. We can directly execute the instruction. And there is also another way to execute this one. We can also execute this the Python programs using files. We can store the Python programs in a file, and because if I execute a program in the interactive prompt, then after closing the session, after closing the window, then the program will be vanished. Okay, but if we store it in a file, then this files will be stored in the hard disk, and we can come back and look at the files. So usually to save programs permanently, we need to write our code in files, which are usually known as modules. We'll discuss the concept of modules later after a few lectures. Like after 10 lectures, we will discuss the concept of modules. Modules are simply the text files containing Python statements. So if I write a program, like this is a file here. So this is a file. If I write a program, if I write a series of programs, and I'm going to name this file, and whenever I save a file, I need to save it with a py extension. So this should be a py. If I give the name as hello, this one, so it should be hello.py. All the files in Python should be stored with this extension. So I'll just show you how to execute these files. So I have something, I've written a file here, welcome.py. Inside this, I wrote three statements, three print statements. In the first statement, I'm printing hello. In the second statement, I'm printing 2 plus 3. The third statement, I'm going to print how are you, okay? These three statements, I stored it, I wrote it in a file, and I named this file as welcome.py. So I stored it in the local disk D, and I named it in the Python course programs. In this folder, I stored it Python file. I stored the Python file. So after, like, I stored it as Python welcome.py, so that the type is Python file. Just because I stored it as a .py extension, the type is Python file. So I'm going to open the command prompt here. So inside the command prompt, our file is in the D drive. So I'm going to go to the D drive here. So inside the D drive, first I'll copy the address, and I'm going to go to that. So yeah, so here, so to execute this file, the welcome.py, I need to type Python, and then I need to type the file name. Okay, welcome.py. I'm sorry, welcome.py. Oh, then the output will be generated here. So to execute any program in a file, we need to come to the command prompt. We need to go to that location. After going to that location, I need to mention the keyword Python, and then I need to mention the file name. So if I mention that, and if I click enter, then the file will get executed. So this is one way to execute Python programs. And as I said, I can also execute here. I can also execute here, like print hello world. So this is another way to execute Python programs. Okay, and as I said, I can also execute the programs. I can also execute Python programs in the Jupyter Notebook. So even here, this is the basic. This is kind of an interactive prompt too. This looks a bit easy for me, so I can also execute here. So this is one way to execute Python programs. Okay, there are so many ways, but mostly to develop websites, to create applications, we use IDEs. We use PyCharm, or some people use Spider. So, but for data analysis, people use Jupyter Notebook. Mostly, people will use these type of IDEs. So, in this course, mostly for the first, at least until we reach the object-oriented programming, I'm going to use Jupyter Notebook, and then we'll switch to PyCharm or Spider. Okay. Yeah. So now I hope you understood. You understood the basic concept of computer architecture. You understood the hardware, how everything works inside the computer. So now I'm going to introduce the Python interpreter to you. Python interpreter is like a software package. It's like a, it's nothing but group of, we can call it like a group of programs, or a group of files which consists different types of programs. It's like a software package. Software package is nothing but a group of programs. Okay, Python is nothing but a group of programs which is called it's called as an interpreter. So the word Python is nothing but the interpreter. Okay, whenever we all download the Python from the Google, whenever we download the Python 3.2 or 3.3 from the Google, then there will be a huge file that we are going to install in our computer. It is nothing but the Python interpreter. We are actually installing the Python interpreter. Inside this software package, we have so many libraries, we have so many programs to execute the Python programs. So downloading the Python is nothing but downloading the Python interpreter. Okay. So Python is a software package called interpreter. A Python is a program that executes another programs. I mean, an interpreter is a program that executes other programs. As I said, whenever we download Python from the Google, a group of programs will, a group of files will be installed in our computer. Inside the files, what we have nothing but the programs. And these are the programs used to execute the Python program. So interpreter is a program that executes other programs. So when you write a Python program, the Python interpreter reads your program and carries out the instruction it contains. So as I said, we write different types of programs. Each program will consist of different type of instructions, and each instruction will be fetched, decoded, and executed one by one. So I can also say that Python interpreter is a loop. Okay, if you have 10 instructions, for example, if I have 10 instructions in a program, this Python interpreter is nothing but a loop which executes each and every instruction. If I have 10 instructions, so this Python is nothing but a loop. First, it will execute this. It will keep on executing until all the instructions are completed in the program. It's like a loop. Okay. So we can also call the Python virtual machine as a loop. Okay. Inside the Python interpreter, we have something called Python virtual machine, which is responsible to execute the programs. It's nothing but a loop. Okay. The program, like all the programs written in this PVM, like all these programs will be executed inside a loop. Okay. Each and every instruction will be executed like a loop. Okay. So from the Python's view, when we execute a program, as I said, like behind like inside the computer, there is a lot of things happening. So the first step is nothing but the bytecode compilation. So in the beginning, I think I told you that the operating system will convert the source code into something called machine code. Okay. The source code will be converted into machine code, or we can also call it as binary code. Okay. This source code and this is binary code. First, the Python interpreter, the main task of the Python interpreter, we need to, like, it will execute, it will not execute, it will convert the source code into the bytecode so that, the operating system can get that bytecode in the RAM and it can start executing it. So the first one is bytecode compilation. Internally and almost completely hidden from us, when we execute a program, the Python first compiles your source code, the statement. Source code is nothing but the statements in a file, okay, into a format known as bytecode. Okay, this is nothing but bytecode. Okay, in Python we call it as bytecode. In Python we call this zeros and ones as bytecode. Okay, so bytecode will be stored with PYC extension inside the I think I stored the welcome.py file. Okay, here, like just a few minutes ago, I executed a program, executed a program inside the welcome.py file. So, whenever I executed the program with the Python keyboard, first it will compile it. Okay, after the compilation, the bytecode will be stored at the PYC extension. I will show this in a bit. The bytecode will be stored in with PYC extension, and whenever the Python wants to execute this program, it will execute this bytecode. Okay, it will not execute the one that we wrote. It will execute the bytecode because executing the bytecode is, it's a bit easier than executing the source code. So when we change the code, then the new bytecode will be created. Okay, when we run the program, like if we change the code, then obviously the new bytecode will be created and the new bytecode will get executed. And this bytecode is Python specific representation. Okay, this bytecode, it can't be understood by the other programming languages. Like we in Java we have something called JVM. This bytecode is not understandable by JVM. We again need to compile it. We again need to change this bytecode into Java understandable form. So bytecode is kind of, it's Python specific representation. In Python, the representation is a bit different. So I can also say this interpreter as a layer of software between a code and the computer hardware. So like here, like let's draw a CPU here. This is the CPU, and this is my code. This is the source code. So the source code is going to converted into bytecode, and the bytecode is going to fetched by the CPU. So the interpreter works as an layer between the CPU and the hardware. This is called the interpreter, Python interpreter. This is the Python interpreter. This works as a layer between the source code and the CPU. So whenever we write a program, the interpreter will come into play. Inside the interpreter, we have something called PVM here. We have something called PVM, and we have something called compiler, which is responsible to convert the source code into the bytecode, and the PVM will execute this bytecode. Okay. So interpreter can be treated as a layer between the source code and the CPU. Okay. So I think we already talked about this. Python program is nothing but a text file. So whatever we write, we need to store it with the py extension here. So I have four statements here: print, print, print. So Python program files are given names that end with .py extension. Okay, like whatever program we write, we give the py extension to that file. Okay. So to explain how everything works inside the Python, I like, this is the basic diagram for this. So this is the memory here. Inside the memory, I have the Python interpreter. Interpreter is, like for example, in the command prompt, like I showed you. Let me show you that again. So in the command prompt, I'm going to click Python. The Python is the keyword to execute any file, and then I'm going to execute welcome.py. So here I'm going to use a keyword, like I use the keyword Python, and then I use the file name here. So whenever I use this one, whenever I use the Python keyword here, and whenever I mention hello.py, the file name, then the Python interpreter, the program of the Python interpreter will be fetched by the operating system inside the memory. So the Python interpreter will come into the main memory, and inside the main memory, then the source code is also inside the main memory. So what the Python interpreter is going to do here is that first the compiler. Okay, inside the Python interpreter, we have something called compiler here. It's divided into two parts. One part is PVM and the other part is compiler. The compiler will first convert this source code into something called as bytecode. Okay, this is called bytecode. Bytecode is usually, in Python we call the zeros and ones as bytecode. Okay, in C we call it as machine code. In different types of languages we use different names. In Python we call it as bytecode. The compiler is responsible to convert the source code file into something called as bytecode. So after compiling it to the bytecode, the PVM will execute this bytecode. First the PVM will again convert this bytecode into the Python understandable form. I mean the processor understandable form. Like I said that bytecode is Python specific representation. Python specific representation. This bytecode, it can't be like the processor cannot understand this bytecode. So it's the responsibility of the PVM to convert this bytecode into an understandable form, like the understandable form of the processor. Okay, the processor need to understand this bytecode. So the PVM is responsible to convert this bytecode into the processor understandable form. So that's how the whole concept of Python interpreter works. It's not that, the bytecode is not executed directly. Okay, the bytecode is again converted into the processor understandable form by the PVM. The compiler. So the Python interpreter is of it's of two parts: PVM and compiler. And also, the Java programs, the JVM also works in a similar manner like this. We have something called JVM inside Java. It also works in a similar fashion. Okay. So we have two parts inside the Python interpreter, PVM and compiler. Compiler is responsible to convert source code into bytecode. And PVM is responsible to convert bytecode into the processor understandable form. Processor understandable form. So this is the these are the functions of these two components of the Python interpreter. So like I said, the instructions are dependent to the processor here. So the bytecode is not sufficient for the processor. Okay, for example, if I have a computer, this is computer A and this is computer B. So if I generate a bytecode in this computer and I can transfer this bytecode to this computer. So inside this computer we have PVM and we have, for example, I can say that we have ARM processor here, we have Intel processor here. So what the PVM will do is that in this computer, in the computer which have the Intel processor, the PVM will convert this bytecode into the Intel understandable form, and this PVM will convert this bytecode into the ARM understandable form. That's the reason I took an example in the beginning regarding the instruction set and the instructions. So the instructions, the instructions are dependent to the processor. Okay, the processor that is understandable by Intel or any other processor. Okay, Pentium or whatever processor that we use, the instructions that are understandable by Intel, it's not understandable by ARM. So what this PVM will do is that first, as I said, so first the source code. This is the source code here. The source code is going to be converted into bytecode first. Then the bytecode will be converted into Intel understandable form. So the reason we are doing this is that so that we can, to fulfill the feature of portability, we can we can send this bytecode to any computer and the computer can execute that Python program without any issues. I mean, we have the PVM, we just need to have the PVM inside the computer. If we have the bytecode here, then the PVM will convert into the processor understandable form and we will execute the program. So that's the reason we use the concept of bytecode here instead of directly converting into the the Intel understandable form or any processor understandable form. We, in between, there will be something called Python. So that's why I told you here we have two components, PVM and compiler. I hope you understood everything here. Okay, so I want to show you the compilation process too. uh, so here whenever I execute this program, the welcome execute this file welcome.py, I use the Python keyword here. So whenever I use the Python keyword, the compilation is already done, but the compilation process is actually hidden, because if I go to if I go to this if I go to this folder here, I can only see the welcome.py file. Okay, I cannot see any pyc file, because I told you that after compiling the Python file, then the compiled, the bytecode will be stored in the .pyc extension, but I cannot see any pyc extension here. I can just see the .py file, because whenever I use this Python keyword here, the compilation process is actually hidden from us. So if I want to if I want to see the bytecode, if I want to see the bytecode file, then I can execute this this program here. First I can import pycompile. Okay, first I'll get me the Python, then PyCompile. I think I did a mistake here. Import PyCompile. Py.compile. Okay. So py.compile. Then I need to use a function. There is a function for this compile. So this PyCompile is nothing but a module. Okay, like I said, it's also a file. Inside that file, there are so many methods. So I'm going to use this PyCompile file, and I'm going to fetch the compile method, and then I'm going to pass this welcome.py file. Welcome.py. So now if I go to the folder here, I can see this one. Okay, I can see the PyCatchy. So this is the compiled Python file, the PYC extension here. If I go to the properties, then you can see the PYC here, .pyc. Okay. Okay. So here, yeah, the type is compiled Python file. So this is the compiled Python file. It's inside the PyCache folder. Okay. So whenever I compile it, but usually when we use Python keyword, this compiling process is hidden from us. But inside, but you know, the PyCache folder is already created. Okay, even though we don't use this PyCompile method, the bytecode is already created. And whenever we execute the Python program again and again, the bytecode will get executed. Okay, this welcome.py file will not get executed. If I execute it again, then this will get executed. Okay, this compiled Python file will get executed. Okay. So once your program has been compiled to bytecode, is shipped off for execution to something generally known as Python virtual machine. And like we already discussed all these points, the PyVM is just a big loop that iterates through our bytecode instructions one by one to carry out their operations. Okay, the PVM is like a runtime engine of Python. It's always present as the part of Python system. Okay, whenever we download the Python from the Google, the PVM is part of these files. Okay, the PVM is inside this PVM. I mean, the PVM is inside this Python, you know, the Python code or the Python files. So we have different versions of Python like C Python, J Python, Anaconda Python, but the basic, the mostly used version of Python is C Python, which is nothing but the C programming Python. I wrote C Python. The reason we call it a C Python is because this was written in C language. So that's the reason we call it a C Python. I think 80 to 90% of the versions that we use is nothing but the C Python. It's the standard one, is the original standard implementation of Python, because this Python was created using C programming language. That, you know, it name comes from the fact that it is coded in the portable C language code. That's the reason we call it as C Python. Okay. And let's talk about some of the features of Python. It is simple and easy to learn, and it's freeware and open source. It's completely free, and we can contribute to the open source. I mean, we can write some code and we can put it in the GitHub and whatever. It's free to use, and it's high level programming level. Like I said, we have two types of languages: high level and low level. Python is a high level programming language. It's portable in nature. Portability is a concept of if we write a program in one machine, then the same program can be executed in the other machine too. So it's portable. It's dynamically typed. I'll discuss about this in the next lecture, but to understand, for the basic understanding, dynamically typed is nothing but whenever I declare a variable, I don't need to declare the data type of this variable. For example, if I declare a variable called movies, and if I want to store a string inside this one, then I don't need to specifically mention string data type. I can just write it as the movies, and during the runtime, the data type will be, you know, attached to this variable. Okay, that's called the dynamically typed. I'll talk about this more in the next lecture. It's both procedure oriented and object oriented. Procedure oriented languages are C language and some other languages. In the past we have some other languages which are procedure oriented languages, which means that the whole code is based on functions. We create functions in C language. We create like functions like this. Like everything is written inside the functions. That's called procedure oriented language. Object oriented language is nothing but whatever code we write inside classes. Okay, that's called object oriented classes. And for these classes, we create objects. We'll discuss all these concepts in the OOPS. Right now, it's not worth to discuss much about these concepts. So Python is both procedure oriented and object oriented. Okay, we can either write a program using functions, and we can write programs using classes too. Okay, we can do both. Interpreted, I can also say that Python is both interpreted and compiled language. Okay, it's not only interpreted, but Python is also interpreted and is also compiled. Because I said a few minutes ago, right? First, the Python will compile the interpreter will compile the source code into the bytecode, and the PVM will then interpret it. It will change it to the the Intel or the ARM processor understandable form. So it can be treated as both interpreted and compiled programming language. Okay. So these are the basic features. Okay. All these are the features: simple and easy to learn, freeware, high level programming language, portable, dynamically typed, and procedure oriented and object oriented, and then interpreted. These are all the features of the Python. So let's discuss where Python is used. Okay. Python is used to develop desktop applications. We have something called tkinter library. tkinter library to create desktop applications. The front end part we can create using the tkinter, and the backend part we can write using classes and functions. So we can develop desktop applications. We can develop web applications using Django. Django is very popular website, but we also have Flask. We have something called Pyramid. But Django is very famous, and Django is also very powerful compared to Flask. But comparatively, Flask is a bit easy. Like Django is a bit tough than Flask, but Django is very popular because Django consists of something called ORM. The ORM mapping concept, which is not very powerful in Flask. That's why people use Django framework more. But Flask and Pyramid is also very powerful. So many companies use these frameworks to develop web applications. So for developing, we can also develop database applications using Python. We can do network programming. Like in the future, I also want to do a course on computer networks using Python. So we'll discuss over there like how to, we'll discuss all the concepts of computer networks. We'll see how Python and other programming languages can be used in networking. We can develop games, like especially in Python, we have a module called Pygame to develop games. So like Python can also be used to develop games for data analysis applications. Like these days, Python is mostly used for these kinds of applications to create AI, to create machine learning algorithms. We have so many libraries in Python, like Seaborn, Matplotlib. We have so many libraries in Python that we can use for data analysis and for machine learning algorithm. We have something called skitlearn for machine learning, and we have machine learning. We can create machine learning algorithms using Python. We can develop AI applications too. We can also use Python for in the IoT, Internet of Things. Like it's a recent technology that scientists are working very hard on this technology. Python is also used in these kinds of technology. So I think that's all for today. I hope you understood all the concepts that I taught.